Hey guys, this is part 6, and at this point you should have all the basic knowledge needed to just get going in Godot on your own. You know how to read the documentation, you know how to find new features, you understand how to organize your code into reusable functions, and you should go learn more about that on your own with better resources that are dedicated to each thing. We're going to keep working on this project a little bit, but this episode should be the last one that has like new information for you. Things that are actually going to help you do better. All right, so reminder of where we were. I think we had just worked on paddle. We got the up and down button working. Let's play it, see what we've got. Okay. We can move our paddles and they will bounce. They are not inverting, so we still need to fix that. The angle on the ball is a little aggressive, so maybe we'll change that. But in general, things are in kind of a working state. So what we're going to do is open up the directory of the project that we're in, and then we're just going to do a git init that will create a new repository for our code to be backed up into. Now, as your project grows, you will want to introduce a git ignore file and keep certain things out of the repository, mostly binary files like assets and that sort of thing. You just want to commit text, really. So like these import files are not going to be useful to us. So what we'll do is we will make a .git ignore. Looks like there's already one here and it's got a couple of things in it. And we will just also do wildcard.import. Okay, so when we're using Git, we've got the repo initialized. We've got a git ignore. Now, if we do git status, we'll see every file that we've changed or is not in the repo yet. As this is our initial commit, we have nothing in the repo. So very lazily for our initial commit, we're just going to do git add, and then dot means everything in this folder, which is just everything. And then we will do git status. We'll see all the things in green are ready to be added. They're all new file. Okay, this is the initial commit, so it's very common to just do git commit -m initial commit. And what that's going to do is if we do git log, we'll see that our very first commit is initial commit. All the files are in the repo now. And if we change any of them, we can review the changes. So let's talk a little bit about why we're starting Git here. We have something that kind of works. The major pieces are moving correctly. And we're going to start making incremental changes instead of building big systems all at once. We're going to fix some bugs. We're going to implement a style guide, which is super important. And as we do that, we want to be able to keep track of it. So it's time to start Git. Now, we did not use Git up until this point because we were kind of exploratory coding. We were figuring things out. We didn't really know what we wanted or where we were going. We planned things out and we took steps, but now we have a little code base that represents the smallest workable version of our game. And since it's now going from a tech demo to a project, we can start it in Git. So we've got an initial commit, and now each commit after that is going to be targeted intentional changes. One of the very first changes we're going to make is implementing the GD script style guide. Now, I don't agree with everything in this style guide. I don't care at all what your style guide is, but let's talk about why you should use a style guide. The purpose of a style guide is to ensure that things are consistent across the entire code base. And what it does is it gives you information that is encoded without actually taking up any space or anything like that. You just make decisions about how things are going to work all the time, always. And that allows you to glean information much faster than trying to read just randomly styled code. So we'll look at some examples in this guide and we'll go through and we'll implement most of it. You can choose a style guide from the internet, you can write one yourself, but your entire team should be following the style guide. Anytime they commit code, they should do a pass to make sure that it fits the style. There are tools that will automate it, but I don't believe in that. So here's a complete example of something with a style guide, not super helpful. So if we go down here, we can see like indentation. Each indent level should be 1 greater than the block containing it. So if we go in 1 from 4, great. If we're less than a tab in, not great. If we're 2 tabs in, not great. And this is going to mean that you can read functions at a glance and not have to figure out why we're 2 tabs in. If we're 2 tabs in, we know we're somewhere else. So when you're declaring an array, it's very common to start the array on one line and then put each thing in the array on its own line. That makes it very easy to read that this is a group of things. Most of these are going to be about making the code very easy to scan, so we'll just scroll through here really quickly to see what kinds of things you should make a policy for. Indentation is one of them. How you set up your arrays and your dictionaries and your enums is another one. For example, your enums being in all caps lets you know that that's an enum, and that's where you should be looking for enums. In programming in general, capital letters indicate some kind of constant rather than a variable, so it's just a good habit to get into. Here we see that they want us to use one blank line inside of functions to separate logic, and 2 lines between functions to separate them from each other. So that's really helpful for scanning, because if there's one line, you know you're still in the same place. Line length comes in when you have somebody that has a ultra wide screen and can fit an entire paragraph on one line. You don't want that because other people are, working on their phones, for example. You want to keep it 80 characters and under. That's just kind of a standard rule. This actually comes up very often for me. You've probably noticed that my display manager will cut things in half very often, and I work in this kind of split screen very often. So I need my code to fit on one half of my screen. It is possible in code to string multiple things together on one line, and just making a rule about not doing that will save you so much trouble when you meet the guy that loves to do one-liners. Boolean operators like and, or not, I will always use the ones on the right. I never ever even think for a second about using the ones on the left. The left is more modern and common, but I'm old and crusty. I do suggest that we should use parentheses to separate conditions. Having a rule like this for comment spacing, where regular comments and documentation comments start with a space, but not could you comment out, can help you while you're working. But I really encourage you to never commit comments or commented out code. Have clean commits. Save yourself the hassle in the future. This note is very helpful. In the script editor, to toggle commenting of a selected code, press Control and K. So what that will do, if we go over here, is I can highlight, let's say, all of this, and then hit Control and K, and it comments it out. So now that code's not going to run. It's very useful. For numbers, I think it's much cleaner to start with a 0 and add a 0. If you're using floats, make it very clear that this is not an integer. I've actually never seen this before, but it's very interesting. I would consider doing this. Apparently you can put underscores in literals, which is just things that are not variables, absolute values. And so you can use it like a comma for very large numbers. That's super cool. Naming conventions is the big one. You want to follow what the engine does so that there's no conflict and confusion when another person working on your project or you, for example, finds a function that starts with an underscore. That should be a built-in or private function. So if we look here, we can see that file names are snake case, class names are Pascal case, node names are Pascal case, functions are snake case, variables are snake case, signals are snake case. And here again, we can see constants are all capitals. This is very common and helpful because when you use max speed, you don't have to wonder if it's a variable. You know that that is just a static value that you're going to be able to use. Having all lowercase file names makes it much easier to deal with on Linux specifically. I think the value of snake case file names is lost on a lot of Windows non-terminal people. But when you're working in the terminal, having everything lowercase means you don't have to hit shift at the start. And having the little bridging underscores instead of spaces means you don't have to escape any characters. Having this as a policy throughout your project also means that you never have to wonder whether the file name is capital or lowercase, whether it's spaces or dashes or whatever. It's always lowercase and underscores. And that is very helpful when you start loading files. Having this consistency for class names, for example, Pascal case, which is where each word is capitalized, means that I know this is a class when I see something that is capitalized on every word. Code order is not the end of the world if you mess it up, but it can make it much easier to navigate your scripts. If we look at our paddle script, it's very easy to come down here to filter methods and just click the one that we care about if we go to assign key. But even having this in order is so valuable. This is the way that they suggest organizing it, and I think it's a totally fine way. I don't obsess too much about this. Static typing is something that you should use as much as possible. That will be a lot of the changes that we're making before we do our next commit. Inferred types is where you enforce static typing, but you don't declare it. So instead of int, you just put the colon in the equals, and it figures out that it's a vector 3. But this is less obvious, and so I don't like it as much. I really prefer declared static typing for as much as we can possibly do. Now, I will link this guide in the description, even though it's easy to find. And we're not going to follow it 100%. We're not going to do every single thing, but making some of these changes will make our code more consistent, and it'll give us a reason to review our code before we commit it to make sure that that's what we want it to do. So, getting into Godot. We're just going to right-click here and close all. We're going to close our paddle scene. We're going to go to main. We're going to go through here one file at a time and see if it's ready to be actually committed after our initial commit. So we'll open up ball. We've got export variables. They are statically typed. Do the names make sense? This is important. Speed, 1010, bounce angle modifier, int 5. In ready, velocity equals speed, good. Okay, we want to make collision a kinematic collision 3D. Oh, almost forgot last velocity. Now, one thing that I do need to consider is whether I want to call this bounce, simply because we are using the vector 3's bounce function here, and there's like a very low chance, but when you skim over this, it looks like it's calling itself, and that is not at all the intention. I think it's fine for now, so we will save this. So if we go over to our folder with Git, we can do git status. We can see that we have changed the ball file. If we do git diff, we can see what the changes are. We've removed the line last velocity. We've put in the vector 3. This is a good thing to get in the habit of looking at before you commit code. It is your last chance to be like, hey, actually, this is super fucking dumb. But it's fine. So we're going to do git add ball.gd. And then if we do git status after that, we'll see that it's green. It's been modified. So then we'll go to the ball scene because we need to check our scenes as well. This is fine as a cube. This is fine as a mesh, collision shape. They're all named well enough. Okay. Icon we didn't use. Main we will review last. Paddle GD. Great, variable inverted. Now we get to ready and it returns void. And that reminded me that over in ball GD, we actually didn't specify a return type for bounce, which is just void. But we want to have that on all of our function types so that I know that this is just doing something, not giving me something back. So we'll change that. We'll go back to paddle, get rid of this needless pass, give this a more descriptive name, invert controls. It's more clear about what we're inverting. That's important. Invert controls needs a return type. So make that void. Okay, get rid of this pass. Sign key is also void. Okay, now this function still has a bug. It's still not inverting properly when we get hit. But that is not what this commit is about. This commit is about implementing the style guide. That's it. Okay, we've got our paddle. We'll go to our paddle scene. Make sure everything looks good here. Paddle's fine, mesh is fine, collision's fine. Main, all of that looks fine. So now we're going to go back over to Git. See our git status, lists all the things that we changed since the last commit. Ball was modified and we had added it to the next commit, but then it got modified again. So we're going to do git add ball.gd, git add paddle.gd. We'll do git status, everything's good. And now we'll do git commit -m implemented style guide. I'm going to put a link to the style guide here because now when I do git log, I can just click this and it'll open it up so I can go straight to the style guide that we're actually using. It's in the Git history. If anyone wants to know if we change style guides at some point, it'll be a clear marker of what style guide we're using. If I was using an internal style guide that's not hosted somewhere, I would put the version number of it. Okay, Now we're back to a clean commit. Nothing has been worked. So we're going to start working on fixing the bug. So purely as a matter of explanation and example, we're going to make a branch. So git branch event bus fix. Then we're going to do git checkout event bus fix. And what that's going to do is going to put us on a separate timeline so that all of the changes we make going forward are not permanent. We can always revert back to everything that we just did. All right, so event bus fix. What is an event bus, you ask? So first we need to talk about signals. Any object, any node can emit a signal. Any other node can connect to the signals of the original object. So if we have, let's say, a landmine and we have a player and we want to know when the player steps on the landmine, this will emit a signal of boom, and anyone that's listening to it will then react to it. The landmine emits, the player connects. To get around this direct dependency, where player needs to know about landmine and landmine needs to know about player, we do what's called an event bus, which is a global autoload singleton. What this means is there is only one copy of this script or object. In this case, it's going to be called events. And so because it's global, it's going to be accessible from any script. And because it's an autoload singleton, it will be automatically loaded into the scene tree at the beginning of the game. Events is going to house some signals for us. For example, ball in goal, ball collided, and maybe reset score. So using this format, when the ball goes into the goal, events will be the one to emit the signal. So let's say we've got our paddles and the ball goes past. It will call up to events, which will then emit the signal to anyone who cares to listen that the ball has gone in the goal. And this will let the paddles reset their position. This will let the ball reset its position. So let the score go up. So anything that cares about the ball going into the goal doesn't need to actually connect to the ball itself. It only needs to connect to events. This is called an event bus. When there's one big object that handles the transmission of the signals so that anything that happens down in the game doesn't have to be directly linked. So this is what our branch is about. Implementing these kind of 3-4 things. Getting the event bus off the ground. Getting it implemented. So to do that, the first thing we're going to do is go to project settings and go to globals. Node name, we're going to call it events. We're going to add an events script. Now, when we start the game, if we go over here to remote, we can see that there's this events node just automatically loaded in, even though it doesn't exist in the scene tree of main. So events, we want to do signal ball collided. Every object has the ability to just emit signals. It is a fundamental part of GD script. So you don't need to write a separate function for that. We can just use it from where we need to. In our ball script, we want to emit the signal ball collided anytime we get bounced. So we're actually going to come down here and just do events.emit signal ball collided. Now that won't do anything because nobody's listening to it yet. Then we'll head over to the paddles. And in the ready function, what we'll do is do events.connect ball collided, and then the name of the function that we're going to use. In this case, invert controls. Leave the parentheses off of this like we would normally do for a function call, because we actually want the function as an object. This is kind of an advanced topic, but it's called a callable, and you just don't put the parentheses, so you can refer to the function directly. Now, we want to remove invert controls from our physics logic. And then invert controls will only be called whenever the ball bounces. So let's put a print statement here so we can see it in action going from the ball to events back down to paddle. Because paddle has been connected and ball has been told to emit through the events singleton. Okay, fantastic. We can see it's bouncing, but we do still have a bug. We're inverting on ceiling hits. which is not something that we want. Now, we could talk about separation of responsibility. Whose responsibility is it to know if the ball hit a wall or a paddle? The ball could only emit this signal if it hits a paddle. But is that what we want? The signal's called ball collided. It should emit any time the ball collides. It can pass an argument along with itself, which I think in this case might make a lot of sense. But what do we actually want to pass? We want to pass maybe some data from the kinematic collision 3D. Let's see if we can get something useful here. Get collider returns the colliding body's attached object. So that should return a paddle, right? So let's pass col.getCollider. Okay, and then we'll just run that. And we're getting errors. So the error is that calling the signal ball collided goes to a function that doesn't take any arguments, but we sent one with it. So we have to go over to paddle, and we have to come into invert controls. So then if we want to keep this format, we have to go over to paddle and add an argument to invert controls. But now there are some problems with this. So if we go to paddle, we know that we need to add an argument here. Something to be passed to invert controls that we can then check if it is a paddle. But it is not obvious what this variable type should be. If you recall from our very first lesson together, every object is a packing of variables that tells us how many boxes each variable gets. And so an object may be 5, 10, and 15 boxes stacked together, one after another. But when you convert from, let's say, a character body 3D down to a collision object, you cut off the extra stuff that collision body doesn't have. So do we want to pass this object as something lower in the inheritance chain than character body 3D? Because we're going to hit walls that are static body 3Ds. And if we pass it as a character body 3D, we're going to get a crash. So let's see what get collider gets. Get collider is sending an object. So we probably want to take an object specifically. So this is where static typing comes in really handy. If we didn't put object here, we would have to go check that chain of events. We'd have to go to events, figure out what's emitting ball collided and from where, and then what kind of thing it's sending. But by putting object here, we know what we're getting along with the signal. So then down here, we can just put col.name as the print, so we can get an example here. See that these are walls. This is paddle, paddles too. Okay, so something that we can do here that is non-obvious, that you'll figure out eventually, is that we can do collider is character body 3D. This will return if it is a character body 3D. So if we hit the walls, it'll say false. If we hit the paddles, it'll say true. And we're just going to show that in the terminal real quick. There we go. True, false, true, false. Okay. But you'll see that we're getting 2 trues and 2 falses for everything that we hit. That's because the paddle script is on 2 different paddles. So this is being run by both of them. If we want to verify that something is us, we can also do collider equals self. And if we run that, then we're going to get false for everything that's not us. We're going to get true for everything that is us. And I think that's what we actually want to do to determine whether or not we should invert our controls. So first thing we're going to do in invert controls is if collider is not us, we're going to return. None of our business. If it's not us that got hit, none of our business. If it is us, then do all this stuff. So you see that this is working. It only goes off once for the one that gets hit. However, our controls are getting inverted because it's running twice. And in the final game, we're only going to have one controllable paddle. So this will be a point that we need to fix later, but not yet. As far as we're concerned right now, this is working. We're also going to take this opportunity to get rid of this initial velocity. It just doesn't do anything for us. We don't need that. So now it'll stop falling at the start of the game and we can move our paddles up and down. Okay, so as far as we're concerned, the event bus is working. and our changes are correct. So we're going to go back into Git, look at Git status. We've changed 3 files and added 2 more. So if we go git diff, we're going to see just the parts of those files that we've changed. And we can scroll through here and get a feel for exactly what we changed. So the first one, ball.gd, we added events.emit signal. That's what we want. In paddle, we added events.connect. That's what we want. We also removed the if and the invert controls. That's what we want. Everything looks formatted according to the style guide correctly. However, in paddle.gd, we can see that there is a print statement left behind from working. We do not want that. So we're going to go back in here and we're going to get rid of that print statement before we commit. So now we're clear. We'll go git diff, see if there's anything else that jumps out at us. Auto load, that's what we want. Down here in project.godot, it's a little less readable than the code. We can see that we just added an auto load, not a big deal. So we will get status, we will get add dot, just adds everything that is red. That's totally fine. Double check, make sure we're not adding anything crazy, and then git commit introduced event bus. You will want to, over time, normalize the language that you use for your commits. If something is appearing for the very first time, I will say introduced. If I'm adding to an existing structure, I'll put added. If I'm changing something, I'll put changed. This will help you later on when you're starting to make devlogs and that sort of thing and telling other people what you've done. Having the language built in like that will help you remember if something's new, if it's old, if you need to update some documentation. So try to normalize your language once you've been doing it for a bit. As far as our branch is concerned, event bus fix has done its job. It's ready to go. So we're going to go to git checkout master. And you'll see that we get all these problems if we mouse over to Godot. That's not what we want. Always close Godot when you're doing Git stuff. So git checkout master will change all of our files from the event bus version back to the old version. If we open Godot now, you can see that it's using all the old code. There's no event bus, there's no auto loads, any other changes we made are gone. And that's because we checked out the master branch, which is fine because all of our changes are still saved on that event bus fix branch. Now we want to git branch dev, like we talked about previously, because that's where we're going to do all of our work. And then we want to do what's called git merge event bus fix into dev. And that'll tell us what we changed, that sort of thing. Check the git log. We're going to see initial commit, implemented style guide, introduced event bus. So the history comes from event bus over to dev. Now, git checkout dev. Good. Let's open up Godot. It's going to take a second sorting itself out, re-importing things, that sort of thing. But now we have our auto loads back and everything is as it was on the event bus fix. So now that that's working, we can do git branch -D event bus fix. That branch is gone forever. Its changes were merged into dev. So now we just work on dev until we have a certain feature we want to work on. So now the next incremental, very small change that we want to make is separating out our paddles from player paddle and CPU paddle, which should just be a very simple renaming of this file. We've changed the player paddle to now be specifically a player paddle. We have deleted the CPU paddle because we're going to replace it with a new scene. Okay, so I've actually gone down a path here that I don't want to do. I deleted my CPU paddle. I was going to separate them into separate objects and do a whole inherited scene thing, but it's way messier than I want it to be. How do I unfuck this situation? Well, first I close Godot. Then I go into my folder, and you can see that I've changed a bunch of stuff. All I want to do is git reset hard. Now that moves me all the way back to when I introduced the event bus. Okay, so we can see that these 3 files are untracked because they're new. So Git doesn't know to delete them. Git clean-n tells us which files would be removed. And then we can just do git clean F to actually remove them. So now we are at a stable working place where everything should be fine. Coming back in, you can see that our paddles are back. Everything works fine. Event bus is in. And it's fantastic. Git saved us in real time. So I think what I actually want to do instead is separate the paddle logically, internally, for whether or not it's a player's paddle. And we're going to make that an export variable, so it goes above the normal variables, and that'll let us toggle it in the editor. Should be much cleaner than what we were about to do. So paddle 1 is going to get toggled on as isPlayer. So then to implement the bool isPlayer, we need to turn off everything that we don't care about if you're not the player. So we're going to come down to input. Don't need any input if you're not the player. And then for inverting controls, we'll put or, which is just 2 vertical lines. And we'll do not isPlayer. We want to also return in that case. If it's not us or it's not the player, go away. And you'll see that only 1 moves now. And that 1 is getting inverted when the ball collides. It's very confusing. Okay, now we're getting somewhere, right? Oh my God. So that is an incremental change. Separating these 2 things is important. So we're going to do this one, which is going to be player paddle. We're going to do this one, which is going to be CPU paddle. And then we will save the main scene, confirm that it's working. So then we'll come in here and we will git diff these things. This main.tscn just means that we renamed it and we set isPlayer to true. Then down here in paddle, we exported a bool variable. We set it to false by default. If it's not the player, we return. And if it's not the player, we don't do any controls inverting. But thinking about it, I actually don't even want to connect this signal to invert controls. So instead of having this here, we're going to move it up here. I'm going to tab this in. And now it won't even connect the signal, so it won't get called every time that the ball collides. It's kind of half a dozen of one, 6 of the other. It's personal preference. This is how we're going to do it. Test it again, make sure it's working. Always test before you commit. Do not commit broken code. We will git diff again and go just change by change. Great. So we can git add all of that and git commit. We separated the player and CPU paddles. This creates a new save point that we can go back to. It's an incremental change. It is one very specific thing. So before we get into like the end zones and resetting the map and all that sort of thing, I think we're going to end the episode here. Today you have learned about Git, about style guides. You've got some idea of an event bus, and that should really be more than enough to get you going. If statements are a contentious thing. I absolutely detest what I'm looking at here. This is gross to me. I want to vomit all over your face.